Okay, thank you very much for letting me stand in front of you and talk to you. You've had the science bit, and now it's time for the pseudoscience. As my father called me when I got my professorship, he said, well, it's only a professor of pseudoscience, it doesn't really count. Here's the problem, though. Andy just noted that one could describe the nub of the problem as the fact that we are inherently selfish. We are consuming energy for our development within our lifetime. So the question is why? Why are we selfish? If I look at this room, I think that's nonsense, because it's packed to the rafters full of people who are clearly altruistically caring about the next generation. So I'd like to argue that, yes, we are selfish, but we're not selfish by desire, we're selfish by default. And the reason we're selfish by default is that it is probably one of the hardest problems to reason and make good decisions about that you could possibly have. And this is why it may be a pseudoscience, but it turns out that the behavioral sciences, and psychology in particular, possibly play a crucial role in the kind of change that we need to sustain. Because we somehow need to get people to understand and communicate the complexities around climate change and behavioral change associated with it. So that's what I'm going to waffle on about for a while. So here's just an example. As the IPCC AR5 report came out, they were doing on The Guardian, the source of all academic knowledge, a kind of running blog or blog of blogs about things that were being said, and this was actually in the post-release press conference, and one of the journalists from the Mail on Sunday, David Rose, who some of you may know as a journalist with a climate skeptic tendency, asked Stocker, who was one of the co-chairs of the working group producing this report, how much longer will the current hiatus in temperature rises have to continue for you to conclude there's something wrong with your models? So one of the problems we have at the moment is, those of us who believe that there is a genuine issue of climate change, is that if you look at rates of climate change, there's been a kind of dip in recent times, suggesting that it's not moving as fast as the models suggest it should. And Stocker answers, those models have shown remarkable agreement with long-term trends we've observed, blah, 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 blah. Estimates are extremely unlikely to be below this. And then Rose says, you haven't answered my question. Stocker says, well, I'm not going to answer it today. And then the clip finishes off. Rose was the journalist who wrongly claimed earlier this month that the rate of warming experienced recently had been half what scientists had predicted. He then had to retract this. So that's against a background of there's clear divisions, there's clear problems with accessing information. You can begin to see why things are difficult to reason about in this area. When Andy put up that graph about how we've basically failed to respond to climate change over every report, you've got this linear increase, well, it's an exponential increase actually, but this increase, every report that comes out, you get more CO2 emissions. One way of thinking about this is causal reasoning. Well, but let's stop doing reports on climate change and then it'll stop, because that must be a causal factor. And whilst that sounds silly, I was at dinner, bizarrely, with Sir John Beddington the week before last, and he was doing a kind of off-the-record description of his dealings with climate skeptics, and the language was blue, I have to say. And he was describing how that kind of reasoning is not atypical amongst the politicians that he has to deal with. He's dealt with secretaries of state who think like that, who think that, who make these very simple causal connections. So reasoning about these things is hard. There's a paper came out a few years ago by Sturman in Science which illustrates some of the complexities of it. So this is my inability to use PowerPoint, basically, and inability to cut and paste the proper graph of the article. But basically that's CO2 emissions going off exponentially at the moment. So what Sturman did and colleagues did, they asked their participants, who were actually undergraduates, I believe, so a reasonable sample of, inverted commas, reasonably intelligent people and educated. They asked them to, first of all, set a network reduction target, so a net reduction target. How much do we need to reduce? And they basically came up with a line like that, which is about right. And then they said, okay, so how do CO2 emissions have to change? How much have we got to reduce our CO2 emissions in order to meet those targets? And typically, the students came up with this picture. So basically, we've got to stop the growth and just sort of plateau off, because that's what's happening with reduction. Okay, and actually, if you think about that, that makes no sense whatsoever. What you need to do is dramatically reduce those emissions. You've got to do something drastic to pull them down. It's not a matter of stopping things getting worse. It's a matter of actively reversing massively what we're doing. But these educated, intelligent, Ivy League students didn't get that. So it turns out that this kind of reasoning about future trends is one of the things people are really bad at. And it's quite problematic. Luckily, I've got a small but almost perfectly formed success story to tell you at the end of this talk about how you can begin to tweak that. So what else makes it hard? Well, here are a few things that make it hard. The evidence that we can select and our access to that evidence. How do we choose what we're going to believe or not believe? It's difficult because even the good scientists are changing their minds a bit, and even they are not getting it quite right yet. So this was another comment that came off the Guardian Online today. John Vidal, who was commenting on it, saying how in 2007 they were talking about a 6-degree rise, now they're talking about a 4-degree rise. I mean, it's still really bad news, but it's changed. So our evidence base is shifting. That makes it very hard, of course, to make judgments if you haven't got absolute certainty in your evidence base. Here's quite a subtle problem, and I'll show you why it's subtle in a minute. The problem of competing alternatives that might both be true. So most climate change believers, most scientists, believe that the underlying cause of climate change is anthropogenic carbon emissions. But there is a lobby that says climate change is a result of natural cyclic behavior. Now, it's possible for those both to be true. Okay, and as we'll see in a minute, it turns out that the fact that you have competing possibilities that can all be true at the same time is very hard to reason about. Perhaps one of the biggest problems, of course, is delay. Delay between action and outcome. Again, taken from this blog, we see a question from a journalist: how can we be sure of predictions over longer term if models can't predict our warming hiatus of late? And the answer comes, there's a large amount of natural variability, so you need to look at it not over 15 years, but 30 years. So in other words, the period by which you can actually start to judge whether your decisions are correct or not, whether your models are correct, has to be longer than people are able to basically deal with. They need immediate feedback on their judgments. So delay is really problematic in getting people to reason properly. Scalability is another major problem. So my wife and I over the years have tried to toy with notions of organic gardening and have laid off the fertilizers and the weed killers as much as we could, only to see our local farmer come and spray us with nitrous fertilizers off the back of his truck when he does the field next to us, and massive weed killing, whatever. So there's a scalability issue there, and the actual scale of the sorts of things that are happening in terms of the individual output of an individual person is very, very difficult to marry up. And people, if you get them to make estimates of the effects of change, they get it wrong horribly. So if you estimate how many people it would take to actually change carbon emissions by their own individual actions, people just can't estimate it. So as a consequence, it acts as an inhibitor for doing anything, the inability to scale up. And of course, then there's the problem of collaboration, the fact that in order to act, we need to act in some kind of collaborative way. We need to own the problem as much as anyone else. And it's very interesting looking at the vocabulary of discussion about how the IPCC confirms what people in the developing world are already aware of, the problems associated with climate change, and trying to make the developed world or the richer countries aware of it too. But political inertia and powerful vested interests blocking this. Collaboration turns out to be a real block in decision making and a real difficulty, because one is aware that you have a locus of control over your own behavior, but you have no locus of control over anyone else's. And that, again, acts as a very big inhibition for people making good judgments that involve changing the activities of others. So a little bit of psychology behind this stuff. There are a number of problems we face. I'm not going to go through these, I haven't got time, but in terms of evidence, access and selection, there's one major problem, which is confirmation bias, which is a general tendency to select evidence that supports your current belief, that supports your current argument. So if you're arguing with a climate skeptic, you're going to be faced with a barrage of confirmatory evidence. And disconfirmatory evidence will tend to be ignored. So that's a real problem. It's not all going to be about problems, this talk, by the way, but a lot of it is. Another problem, which is quite subtle, is there seems to be a cultural difference in the way we use evidence to test our hypotheses. There's some work by Richard Nisbet showing essentially a Western-Eastern difference in the way we treat evidence. So if you take a stereotype, and apologies if this sounds rude, take a grossly misleading stereotype like all women are bad drivers, okay, and then you say, well, here's Rachel. Rachel's actually a really good driver. Now, according to Nisbet's studies, the effect on a typical Western adult thinker is that it kind of confirms their original stereotype. Yeah, well, okay, Rachel's a good driver, but she's the one that she's the exception that confirms the rule. But it's still, nonetheless, most women are bad drivers. So it kind of adds to it. Whereas an Eastern kind of way of thinking says, oh, well, hang on a sec, if Rachel's a bad driver, then maybe I'm not so sure that women are bad drivers after all. So you get some fairly major cultural differences in the way that individual bits of evidence are used to justify or falsify arguments. And I think these kinds of subtleties need to be understood better when we're using evidence to justify different positions about climate change to different audiences. Let's come back to this competing alternatives problem when you've got two explanations, two hypotheses that might be true. So here's a sentence. If it's raining, then the pavement will be wet. Okay, pretty much everyone will agree that's true. And I tell you, on Thursday it rained. Almost all of you, but I suspect all of you, would conclude the pavement was wet as a consequence of that fact. That's a modus ponens inference for the logicians in the audience, and it's one that we automatically draw with ease. Now, if I say to you, also, if the water main bursts, then the pavement will be wet. So both of those can be true at the same time. And then I come back to you and I say, on Thursday it rained. Then you're less likely to endorse or generate that inference, the pavement was wet. It doesn't make any sense logically whatsoever. But the very fact that you've got competing possibilities for the same outcome makes people essentially lose confidence in something they were previously completely confident about. And that's a real problem for the climate change debate, because you have these plausible hypotheses competing against each other, which may lead to the same outcome, but the existence of having two of them leads to having doubt in the first of them. So, it's time for a bit of good news, I think. What can we do to change people's behaviour? This is a recently published study, so recent I haven't read it yet. Well, I've read most of it. But it's kind of interesting. In a way, it's quite scary, because it's a study by Rudman and colleagues, and what they do is they look at people's implicit attitudes towards politicians who hold green views or who don't hold green views. So what they did was they asked a bunch of people explicitly, what are your feelings about these two politicians, one who's green, the other who's not? And pretty much everyone said, oh, we think the green one's the good one. And then they did what's known as an implicit attitudes test, where they got people to respond very quickly to recognizing characteristics about these people. And they found that people's responses were much quicker to the non-green one, the one who was going to basically get them more money through tax lowering and that sort of thing, suggesting that there was a dissociation between their implicit beliefs and their explicit beliefs. So they may have believed that doing the green thing was good, but actually, because they are, they're selfish by default, they are responding quicker to the views of someone who's basically about making money and so forth. So what Rudman et al. Did was they then sampled a similar group of people after Hurricane Irene had hit the United States. And what they found was that people's experience of being in that being caught up in that hurricane, or seeing people who were caught up in it, changed not only their explicit belief towards a more green one, but also their implicit beliefs. So the bad news is we've all got to be involved in a hurricane before we'll change our mind. But the good news is, if we get involved in a hurricane, then we will change our minds. Now, Rudman and colleagues think there are ways you can do it without actually putting people in the middle of hurricanes. They believe that with proper educational programs that actually begin to link people's understandings of events that happen with potential causal mechanisms behind them, you can get the same effect without actually having to experience it. But I think one of the really important things is that, coming back to this notion of selfishness, I don't think any of us believe that we're selfish, and I think we all believe that we want to do the environmentally good thing, but we have spent a lifetime of trying to experience personal gain. And so implicitly, we're set up to gather things for personal gain more than to do the altruistic thing. That's a real problem. This is some work from Denise Hilton, and it's looking at what happens when you give people incentive-based information, tell them about, how much they're saving as a result of doing the green thing, if you like. So basically, you gave people very sophisticated feedback on their energy use and told them they would save X amount of money by saving energy. And one group, he just gave that descriptive norms about how much you're going to save. And another group, he gave descriptive norms with also a kind of what he called an injunctive description, which was a kind of, you're doing the right thing. This is the best way to do it. This is really an excellent idea, if you like. Positive feedback associated with giving them the descriptions. And what he found was that giving people feedback made very little difference if they were low consumers anyway. In fact, it made them use more. But if they were high consumers of energy, they used less, so that the money worked to sort of say, oh, I'm not spending very much, I can spend some more, or oh, I'm spending lots, I'll spend less. But you've got a really big effect in terms of dropping consumption when you combine the fact of you're saving money by not using energy, and you're doing the right thing as well. It's a very simple message that comes out of this, actually. If you're going to give people incentives to change behaviour, actually attaching a message of communal altruism to them makes them more effective, which I think is a really positive outcome of that work. But he also has another study that says if you just give people positive altruistic messages without the feedback on their actual consumption use, you get no effect at all. So you've actually got to combine the two together. Something that I've done recently, and I have to admit it's a pilot study based on about, just under 30 people. I was very struck by this problem that Sturman pointed out in terms of people's reasoning about what kind of change is needed to reverse a problem. So I did a bit of reading around the subject, and it turned out that if you want to change people's reasoning about the future, then if you personalize it, if you make them evaluate future states in terms of themselves, which equates very well to the selfishness by default problem, then you can start to change the way they reason about future events and get them to be more normatively correct. So I just took the Sturman example, and instead of making it about CO2 emissions in the world, I did it about CO2 emissions from your house. So this is you in your house, and your emissions have gone up like this. But I had to change the timescale, obviously. So I gave them a timescale which went from 2009 onwards, and looked at household release of CO2. And I claimed, because it was a simulation, that it had gone up like that. And likewise, I got them to estimate a net reduction. And then I asked them the same question. What kind of change needs to happen to your household emissions to meet that net reduction target? And we got a much sharper drop down. When it was personal to them, they could see somehow how actually you've got to do something quickly to meet a target like that. So with the same people, I had them in two groups. Proper Science designed this. And in one group, I gave them the climate example first, followed by the house example. The other group, I gave the house example followed by the climate example. And I looked at what I've pretentiously called the average estimated quartile growth, which is how much the line went up in between each of those data points on it. And what you see is a 3% growth when you give them the climate change example first, and 22% drop when they then get the house example. If you give the house first, it's approximately the same, a 20% drop. But the good news is, if you give them the climate one after that, you get a 14% drop. So there aren't enough data for me to publish this yet, but it's indicative that if you use a simple process like analogical transfer, transferring from one example to another, and combine it with the fact that people seem able to reason about personal events, personal future events, easier than they can about global future events, you might begin to find ways of changing people's comprehension about the effort necessary to affect climate change. And I think I'll stop now.
Tom, that was great.